This is part 3 for the review for test 1 in advanced functions and modeling. If you have any questions on anything 1 through 15, numbers 1 through 7 are in part 1 and number 8 through 15 are in part 2. This is just going to cover the last two, 16 and 17. So it says the table at the right shows the height of water in centimeters in a pitcher in the desert as a bald eagle places rocks in it. Why this would happen, I don't know. Use the table to answer the following questions. So first, plug these values into your calculator and run a linear regression to find the line of best fit. What is the equation your calculator finds? So you need to go to your calculator, and to put it in your table, you go to Stat, and then you hit Enter, where it says Edit. So I've plugged these in already, so it would save us some time on the video. So I have the same thing that we have here. It's the same table. Now to run a linear regression, I go to Stat again, and then I go to Calc, and then 4 for linear regression, and just hit Enter until it calculates it for you. So there it is. Y equals, and we'll go to 3 decimal places, 3.893x plus 0.429. So then part B asks, what is the slope of the line? Well, let's go ahead and take care of that. The slope is the number in front of x. So the slope is 3.893. And this says, what does the slope mean in terms of the problem? Remember, slope is always your change in y per x. So in this case, it's the change in the height of water per rock placed in the pitcher. So it means that this is the increase, or let's write it this way, the height of the water increases by 3.893 centimeters for each rock or per rock placed in the pitcher. So it's the amount of y, the height of water, that changes per x, the number of rocks. C says graph the line in your calculator. So go to y equals, we'll plug this in, 3.893x plus 0.429. Look at the graph. So it says graph line on your calculator. How would you describe the line? Well, it's increasing. That's really all I'm looking for there. It's increasing. We'll add more descriptions as we go on through the year, more things we can say about that, but for now I just want you to tell me that it is increasing. Okay, part D, what is the Y-intercept? Well, the Y-intercept is the number that's by itself, so it's 0.429. What does that mean in terms of the problem? Okay, the Y-intercept is always the amount of y you have, so the height of the water, when x, the number of rocks, is 0. So it's the height of the water when no rocks or 0 rocks are present. You could say it's the height of the water before the eagle drops any rocks in, something like that. And that does make sense. There's got to be some water in it to start with. Part E. Using your equation from part A, determine the number of rocks needed to bring the water level to 40 centimeters. So water level is our y, so we're going to plug in 40 for y and solve for x. Okay, so I'm going to subtract 0.429 from both sides. You get 39.571 equals 3.983x. So then just divide both sides by 3.983. Oh, sorry, 893. And we get 10.165. So that is the number of rocks it would take to bring the water to a level of 40 centimeters. In part F, using the equation in part A, determine the height of the water when 10 rocks are placed in the pitcher. So that means we put in 10 for x. So we have y equals 3.893 times 10 plus 0.429. And that one you can just plug completely in your calculator. 3.893 times 10 plus 0.429. And it's going to be 39.359. So that turned out pretty similar to our other answer. 39.359. Okay, last question on the review sheet, number 17. The table below shows the number of minutes each that people exercise per week and the number of headaches per month each person experiences. Use the data in the table to answer the following questions. So A, using the first and last points of data. So I'll be using 26 and 122. Write an equation of a line that could be used to model this data. So I've got the points 26 and 122, and I need to find the slope. So I get 2 minus 6 over 120 minus 20. That gives me negative 4 over 100. So you can leave it like that, or it'll reduce to negative 2 over, or actually reduce to negative 1 over 25. So that's our slope. And then I can do y minus y1 equals m times x minus x1. So I get y minus 6 equals negative 1/25 times x minus 20. So y minus 6 equals negative 1 over 25x plus 20 over 25 reduces to 4/5, and then add 6 to both sides. So I'm getting y equals negative 1/25 x plus, it'd be 6.8 or 34 over 5. So that would be the equation of the line that could be used to model this data. So B, what is the slope of your equation in part A? Again, our slope is the number in front of x, so it's negative 1 over 25. If you want to use the decimal, negative 0.04, that'd be fine as well. What does that mean in terms of the problem? Well, here's our x and here's our y. X always comes first. Slope means the change in y per x. So we would guess that on average, the number of headaches, that's the amount, the y, number of headaches decreases, because it's a negative slope, 1/25 per minute of exercise. So the change in y per unit of x. So we would guess the number of headaches decreases 1/25 per minute of exercise. Another way to say that would be, we would guess that for every 25 minutes of exercise, you think your headaches would go down by 1. C, what is the y-intercept? So again, the y-intercept is the number by itself, so 34 over 5, or I'm going to say 6.8. I think that'll make a little more sense in terms of the problem. So what does that mean in terms of the problem? Well, the y-intercept is the amount of y when x is 0. So it's the amount of headaches we would expect to get when we exercise 0 minutes. So the number of headaches when you exercise 0 minutes, or when you don't exercise. And then finally, part D, using your equation from part A, predict how many headaches the person who exercises 140 minutes per week would expect to have. Well, minutes exercised is x, so I'm going to plug 140 in for x. So I get y equals negative 1/25 times x, which is 140, plus 34 over 5. And I can just plug this straight into the calculator. Negative 1 over 25 times 140 plus 34 over 5. So we would expect 1.2 headaches for that person per month.